Hello. I'd like to welcome everyone to Intaver Institute's webinar series. My name is Michael Trumper. My official title at Intaver Institute is Business Development Manager. I've been here since 2003. In reality, I'm one of the partners, and in addition to business development, I'm also work as a trainer, do some consulting, testing, and have a hand in developing our software requirements for some of our future versions. So I do have a fairly good grasp on the software and the topic. We're providing these free webinars to help our users understand how they can use specific features in RiskyProject to improve their project risk management and analysis. What we want to do is focus on a specific feature, discuss when it is appropriate to use it, and then provide a quick demonstration as well as some time to answer your questions. Hopefully the goal is to have it done in between 30 and 40 minutes, so we're not taking up too much of your time. Some time to go over some housekeeping on how you can participate in the webinar. So when you signed in, you should have a little console at the top, on the top right. You see this outlined here. You can either join using the mic and speakers, which is the preferred, or by telephone. And you can submit questions in the questions dialog box here. If you answer them, what I'm going to ask you to do is hold on. You can type in some questions during the presentation, but I'm going to hold on to answering them until after the presentation is completed. You can see at the side right here, here's my information, my email. It will also be in on the slides, and we're hoping to have this recording up very quickly on the website. So if you want to get a copy of that, you can go to our website and download that. Okay, so today's webinar is going to be what-if analysis in RiskyProject. One of the points I would like to make up front is that the what-if analysis is a feature that's only found in the professional version, as it is considered a more advanced project risk analysis feature in our software. So if you have a light version, you're not going to be able to see this capability on your software. If you think it's useful, it may be worth your while then to upgrade to the professional version. So what is what-if analysis? What-if analysis, you might have heard it as branching. It's where we can model scenarios where two or more possible paths succeed in activity. So I've just highlighted again that it requires an activity that has at least two possible successors or branches. There's two types of branching that we'll be looking at today. One is probabilistic, and the other is conditional. And they're appropriate for two different types of situations that you might come across. So probabilistic branching, what are we trying to do? Well, we're trying to calculate the expected value, EV, if you see that, that's stands for expected value, of the project where we cannot determine up front which branch will be taken. So we have a project where there is a branching that can take place, but at the time of the project planning, we don't have an idea about which branch we're going to be taking at that particular time. Very common to be used in testing environments or where there is a test that's going to be taking place, and there is a pass and fail branch. So what happens if we pass, we move on to one activity. If we fail, and especially in this branching, it's where you're going to be going into a recovery type activity where you may be going through and doing some analysis, some more design, and then a little bit more construction, then go through, and then you'll be able to go on and continue down your project. Each one of these branches, obviously, because we're talking probability, has a probability that will go down one branch or another. And again, how you come up with that probability really is going to depend upon your, as it is with a lot of the risk management, some of your subject matter experts, expert opinion, and history, and again, taking a look at some of the unique features or activities that you might be taking place within your project. So we're looking at this one. So if we're going to be doing a failure test, probabilistic branching, where we do have a test and there's failure. The test will have a probability of failure, and the test activity becomes a conditional branch. So we'll have a pass, as we said before, percent pass. We go on to the next phase of the project. Percent fail, we go into the recovery activities, and then we go on to the next phase. So what I'll do is I'll just show you how we might look at that. On a very simple looking project schedule. So I'll just wait. We might have some lag as we move into the software. So what you can see right here is we have a very simple project schedule. I don't want to go into anything too complex. We do, if you look at it, what we do is have a branch where it's probabilistic branch. We have one branch where we're going to where we're going to build, and the first branch is going to be we're going to design, build, and test, and the fail branch is we're going to do analysis of what happened, plan, build, and retest. Now I just was looking at this and it turned on me, so I'm just going to open this up and this sorry about this. Now if you look at this, what we're seeing, we have two branches. We've done some design, and what we have here is if we go to the branching, and I've broken that. We'll just show this, and we're going to link this up, and I'm going to link this up. So what we have here, as you can see, is we have, when we do the linking, we have two conditions, and we can put in, for probabilistic branching, we can then put in a percent, that we assume that we're going to pass based on past history, and there's a percent that we're going to fail and we're going to go down. And percent that we're going to fail and go down, and that we're going to have to go through a recovery stage. So what we've done is we've set up a branching. We have two branches. We have a closeout that it'll go down to. And what it does is shows on RiskyProject. You'll see that normally we have blue lines that show linkages. We'll have green lines that show that we do have some branching. And then we can just calculate. And we can get some analysis out of here. To see what our expected value of the project is. So what we can see here with our branching is we've set up when we'll get a finish time, and we've taken into account there we go. We've taken into account our that we have a project that has a success branch and a failure branch, and what the cost of would be if we have to go through a failure branch. So it's a pretty simple and quick way to set it up. However, the advantage of this, rather than doing, let's say, through a risk drivers and saying we have a risk of failure and we're going to put in a delay on there, is that what we can do is we can actually build in, it's like a mini project. And what we do, if you can see that we've actually put uncertainties, we could also, there are risks that we can, if you're more familiar with the RiskyProject, that we could put risks and assign risks to the schedule, to the mini schedule on the fail branch that takes into account risks that are going to be associated with these new activities. So we get to have a much more realistic and concrete understanding of how the risk or the fail branch is going to affect our project schedule. So this is just an estimate of how we would set up a probabilistic branching. Just move on to conditional branching now. Now, conditional branching is a bit more interesting, I find. It's used to determine the expected value of a project under certain conditions. And it's conditional. So what we do is we use the predecessor that has two branches, and under certain conditions, if that predecessor meets these conditions, we will go down one branch or the other. So the conditions that we have on here could be task duration, task costs, task start time, or task finish time. So typically, conditional branching, we're using these conditions as triggers that will cause contingency paths to be executed. So it's very useful process to set up when you're looking at contingency planning based on facts on the ground. Sort of when you're going down a project, you say, if we don't meet a certain deadline or we don't meet a certain cost, or things are going slower, we're going to have a contingency plan in place that we will, if we meet certain, and we get to a certain point in the project, we haven't met where we want to be, we're going to go back down and we're going to execute. We're going to go down and use this contingency plan to bring this product or to complete this project on time. So often very useful when you're developing new products. An example might be that you have two designs. This common example, you have two designs. You have a preferred one. But it's risky due to that you're going to be bringing in new technology. So there's a lot more uncertainty and risk around taking this preferred route because of this new technology. But you want to go that way because it's going to bring some more capability to the product, may add more value to the product. Obviously, maybe in the end you'll get be able to sell the product for more, or it's going to make your clients happier. The contingency one is that we're going to use you will have a secondary fallback position where you're going to use a more standard design with off-the-shelf, or maybe off-the-shelf technology, and we know that we can get that done in time. And if we don't meet a certain condition, we're going to switch to this fallback position. So the contingency we have is we're going to switch to alternative 2 if duration for design 2 is too long. So how does the logic, if we want it as a logic statement, if design phase for A is, in our example, is greater than 110 days, then we're going to cancel construction A and set duration to 0. If design A phase for A is equal to or less than 110 days, then we're going to cancel the construction B and set duration to 0. So what in this project, what you'll see is that we're going to be designing. They're going to go through and they're going to have design A and design B both going at the same time. And what we want to model is how often we're going to be under 110 days, or 110 days and under. And if we can do that, then that means we can go down the preferred method and construct the product using design A. If it's going to overshoot that, means we're not going to meet. Maybe we're not going to meet our deadlines. We're going to go down and we're going to use the more standard design, and we're going to go down the construction B path. So it's going to look something like this. We have a kickoff, we have an alternative 1, we have a design and a construction, and we have an alternative 2, which is design and construction, and then a closeout. And what you can see about this one is the design one, because it's got some more uncertainty. It's a new design, maybe new technology. It's taking longer. So at the base, we think it's going to take 30 more working days. We've got some uncertainties around it, and so we want to know that most likely is 100. But if it goes over 110 days, that means we're going to switch to design B and go to and then go down to this construction phase in alternative 2. So let's just take a quick look at that, what it looks like. In the software. So what we do is we have a kickoff. You can see that we have this in the project. You can see that we've put in some uncertainties, as you showed on that table. Now the conditional branch here, the successor, is actually design and it's conditional on the results that we actually get out of this activity here. So if we take a look, we'll just open it up and take a look at the branching. So we can see the two successors. We have number 5, which is this construction here, and number 8, which is this construction here. And what we have put in, if duration, we have all these conditions that we can put in. We're just going to be using duration for simplicity's sake. If the duration is greater than 110 days, then we're going to cancel this branch and set duration to 0. Now on the other side of it, on construction 8, so that was for 5, and in construction 8, which is this one right here, if the duration of the design on activity 4 is less than, that should be 110 days, less than or equal to 110 days, then we're going to cancel and set the duration to 0 on the construction, because we're not going to do that. So what we've done is we've put in a model where we're either going to go down this construction or this construction. What we want to get is the expected value of the project based on that, on what will happen if we switch from one mode to the other mode, depending on what the condition is of the design activity for design A. So we'll just run a quick calculation. And what we can see here is if we go to the project summary, typically in this type of, and it's a bit more obvious here, we have a very much a bimodal histogram where we're seeing the results of the two branches that we've gone down. And so this one right here is we're probably seeing the success, we're seeing the failure. When we look at the duration, which will give us a better chance to see, you can see that again we have this very bimodal looking chart which shows us this branching that's taken place. Always like to take a look and see in the design construction phase. We'll just go into probability, and what you should see again, just to check this out, is that on the duration we can see that we do have this bar right here which shows those are the amounts of time that the activity was canceled, the construction, that we didn't go down that path. And if we look at this, we can see over here that's at 110 days. We didn't quite make it to there, so we went off. And another way to look at it is look at the data. We can see how many times during the data run, I think we run 1,000 simulations on here, you can see how many times we didn't meet that criteria. And it looks to me it's somewhere around 30, and you can look at that, it's 32% of the time we didn't make it down that path. Again, we can take a look at this construction, take a look, and we see that same sort of that same pattern. Again, we have a high probability of them. 60, we're looking at that 60-something% probability that we won't have to go down the contingency plan. So we're successful. We've got quite a high success rate. And here's the probability again that we're going to go down here. And it looks at the time that it's going to take us to actually run that. The contingency construction is quite low. It's around, probable would be right around 54 days or so. So we get a chance to take a look and the average on this is quite skewed just because we have a large percentage of the activity ever occurring. So what this does is this contingency planning allows us to quickly set up our project. If we are going down a development path and we want to ensure that we're going to meet a delivery date, you may have some penalties involved, but we have a preferred method, and we do have contingency development going on underneath, that we can model this and get an expected value of how long it's going to take us to expected value for the project, expected value of how often we're going to be able to get down and go down the construction of our preferred model versus our contingency model. So very quickly we've been able to solve one of these problems. And again, we often have a discussion about, should this be a risk event? Can we set it up as a risk that we're not going to meet our construction dates for the preferred model on our design? And this provides a lot of benefits in that we can, not only do we get to model it in more detail, we can again obviously put in some of the risk drivers and some of the uncertainties that you get with any activity in your project schedule, and you can build that in fairly quickly. And it's very visual. We can see where it is. We can see it on the project schedule, and it allows us a really solid model to understand up front what our chances are given the current status of the project and our goals. What are the probability that we're going to meet our preferred goal and B, our contingency model. Oh. I hope you can hear. Sorry, my mic was sliding down. I hope everyone can hear me a bit better. So briefly, that is our talk for the day. It's only taken about half an hour, which is our goal for these, is to have a nice brief blurb to give you something to think about. Who's attended. If you have any questions, now is the time to, we'll take a look at, I can answer some. I've got one. It says, are the probabilistic results of the branching incorporated in the baseline so that performance can be analyzed? If you're doing it within RiskyProject, if you're tracking actuals, yes, it will be incorporated into the baselines. It becomes a bit trickier if you're running it from Microsoft Project, about how you want to bring the actuals into RiskyProject so you can get those take into account actual project performance. But yes, it is the branching is incorporated into the baselines, or can be incorporated in the baselines. Mostly, we're going to see this though at the planning stage. Is where this is especially useful. Is there any more questions? So we have one that's, can the simulation results be written to a file for post-processes? We can take the simulation, one of the simulation results here, they're not going to be written to a file, but I can take all of the results from, let's say, the finish time, duration, any one of these charts, and copy the statistics or the data, all the run data, to the clipboard and post them into Excel. That's the quickest way to get the data out and put it into Excel where you might want to do some other analysis on there. you can we have some reporting views again, which we can grab the data off the reports, and we can obviously add as many columns in here of the data that you want. Grab that data and throw it into again, throw it into Excel, paste it into Excel, and run your analysis on there. I hope that answers your question. So how does this capability compare to that of Vanguard product capabilities? I would say is that Vanguard is really it's a decision analysis tool. If you actually look in our if you look in our launch menu, we actually are able to create a decision tree out of our schedule and launch it into save it into as a decision tree that can be launched and opened up in Vanguard. So we see them more as a complementary aspect. Again, ours is our tool is optimized for project schedules with risk drivers, and you can bring that all into the fore. The Vanguard is very much a complementary tool that we can see as being part of the continuum of the decision analysis framework that you want to have to bring to bear in on your project analysis. Okay, I just see one that says show us a method for cost model. What I'll do is I'll actually get a hold of you. I don't want to get into that and set up a model right away during the week. We're going to run out of time on the webinar, but I would be very happy to talk to anyone and set up a quick webinar or web meeting where we can go over and show you how we can do this on the cost model for the branching. So that's always something that we're willing to set up, and it's very simple to set up. We can do it very quickly, and we have if you're not in our time zones, we're pretty flexible to be able to work with our client base to help them out with their problems. So I'll just send if you have any questions and you want to, regarding this, if you'd like to set up a quick web meeting that we can go over anything you've seen here, or you have any specific questions or problems that you want to take a look at, I'd be happy to go over those with you and see if we can solve some of the problems for you. At this time, we're running at about, we've gone about 35 minutes. If there's no more questions, I'm just going to close it up. I'd like to thank everyone who attended. If you want to take a look at on our last slide here, here's our contact details. We do have some additional resources if you want to take a look at what's on our website. If you do have any questions about this webinar or anything else, please feel free to contact me. Our next webinar is scheduled in May, and this again will be very specific to RiskyProject, little pieces of it. We are planning a webinar in the next, at the beginning of April. You'll probably get an email in regards to that, and that will be specifically for the energy business, oil and gas, with a focus on that. That'll be actually looking more at larger workflows that if you're in that sector or you're interested, we're going to be having one. I believe it's on April 5th That's not confirmed yet, but it'll be in the first week or two of April. Will be the next one, but it's not really part of this series. It's specific for an industry. In May, we're going to be focusing on our the webinar will be focusing on reports, and again, it's some of the stuff that was brought up. How do we get the data out? How can we get some of the raw data out and put it into other software where we want to do some other analysis? We'll be addressing those type of questions. Okay, well, thank you very much. I'll close it up with today with a thank you, and I hope to see you in either April or May, and look forward to hearing from you if you have any questions. Thank you very much.